Hello everyone. Let us now discuss how can we solve this problem. Count number of trapezoids 1. So we are given with a 2D integer array points where points I is equal to xi by I representing the coordinates of ith point on the Cartesian plane. So a horizontal trapezoid is a convex quadrilateral with at least one pair of horizontal sides parallel to the x-axis. Two lines are parallel if and only if they have the same slope. So it is nothing but these two lines are parallel. So this will make a quadrilateral, right? And it is known as a trapezoid. So this is what a trapezoid means. Now you might ask me, what if it is something like this, right? So these two are parallels. Now these two are parallel vertically, but this is a quadrilateral, but it is not a trapezoid. They said the trapezoid is a convex quadrilateral with at least one pair of horizontal sides. Horizontal means those which are parallel to x-axis. So this isn't a trapezoid. Now, return the number of unique horizontal trapezoids that can be formed by choosing any four distinct points from points. Since the answer may be large, return it modulo 1 in 9 plus 7. Let us see what are the constraints. Points length will be at least 4 and at max 10 power 5, and xi yi values can be from minus 10 power 8 to plus 10 power 8. All points are pairwise distinct. Now let us look at an example. 1 comma 0, 2 comma 0, 3 comma 0, 2 comma 2, 3 comma 2. I have just mentioned those points, or I have given those points in this Cartesian plane. Now 1 comma 0 is here. Now let us see how many trapezoids that I can make with different colors. I'm using this color blue for one trapezoid, right? One trapezoid. Now I'm using another color green for another trapezoid here with 2 comma 2 with this point, and 2 comma 0 with this point, and 3 comma 0 with this point, and 3 comma 2 another point. Now I'll be having orange color for another trapezoid. So I'll be having this point again. I'm just marking it, right? So 2 comma 2 is one point, 1 comma 0 is another one, 3 comma 0 is another point, 3 comma 2 is another point, and I'm just making a line. So there are totally three trapezoids that I can make. So totally right, I think there are no other trapezoids that I can make. Now I have another points example: 0 comma 0, 1 comma 0, 0 comma 1, 2 comma 1. Now let me just take a trapezoid like this. Now these two are horizontal lines which are parallel, so there will be only one output. But let me take another example where I'll be having this one, right? Now after that I'll be having some points. Now I'm just making some points here: 1 2 3 4 5 6. 1 2 3 4 5 6. Now 1 comma 4, let me mark these points: 1 comma 4, and 2 comma 4, 3 comma 4, and 4 comma 4, 1 comma 3, 2 comma 3, 1 comma 3, and then 2 comma 3, 1 comma 2, 2 comma 2, 3 comma 2, and then 1 comma 1, 2 comma 1, 3 comma 1, 4 comma 1, 5. Yes, these are all the points. But before solving this by manually, let us check how many points, how many trapezoids that I can make if I have 4 points here and I have 3 points here with this as my upper side. I'm just selecting upper side from this point. So and I'll be having 2 points here. So 1 2 3, right? 1 2 3. Let us just ignore this for now. Let us just ignore these points of x coordinate. Now I have this at 3. At 3 y is 3. Now I need to select only 2 points from every row. I'm just considering it as a row, right? So only 2 points. I can select these two. I can select these two. I can select these two, and also I can select these two and these two and then these two. So how many points did I just make? How many pairs did I just make? One, two, three, four, five, six. But which is nothing but 4c2. Let us see whether am I correct or I am just missing something. 4 factorial by 2 into 2 factorial into 2 factorial. 4 into 3 into 2, and 2 into 2 will be cancelled out with 4, so 3 into 2 6, which is nothing but 4c2. I can just make it as n into n minus 1 by 2, 4 into 3 by 2, which will give me 6. So nc2 is nothing but n into n minus 1 by 2, which you already knew, right? So I just got all those 6 pairs. Now, these 6 pairs I can make with how many pairs I can make with the point 2 at this row 2. So let us see. I can make these two as the bottom. I can make these two and make a bottom line. I can make these two and make a bottom line. So from these three, how let us see how many ways I can make a bottom line. That means selecting 3C2, 2 points from 3 points, which will give us 3 into 2 by 2, which is nothing but 3, right? So from 2, I can just take only one pair, right? So what is my intuition is, with this pair, I can make, with this just one pair, I can make this pair, right? This one, or I can make this one, or else, right? I had make one and then two and then three, right? Let me wait a second, right? So I'm making the first pair as this one. Now the second pair is this one. That means second trapezoid. Now the third one will be this one. So for every point, every pair, instead let me say that for every pair, for every pair, I got I got 3 pairs, right? So for every sorry, 3c2 into 2c2 are the number of trapezoids that I can make with this. Now I will add that to 3c2 and 2c2. Sorry, it is not 3c2. Sorry for the mistakes. So I have 4 points and I am selecting 2 points from that. Into I got 3 points here, right? So 3c2. This is nothing but the upper line selecting from 2 points from 4 points and selecting 2 points from the 3 points here. Plus I will add that, and from this I have to add these 2 points, how many pairs or how many lines I can make with these 2 points. So 4c2 into 2c2, right? So now with this I had made this, right? I had made all those trapezoids. Now from this I can also make this, right? So I am selecting this as my top line and selecting this as my bottom line. Plus 3c2 here, 3c2 plus 2c2. So this will be our answer, right? But here if you see, if I write 4c2, that's what I need. 4c2, 2c2 and 3c2 and then 5c2, right? So let us see what are the values, resultant values. 4c2 is nothing but 4 into 3 by 2, which is nothing but 6. 2c2 is nothing but 1. 3c2 is nothing but 3. 5c2, let us calculate 5 into 4 by 2. 5 2s are 10. So these are the number of lines or trapezoids, upper line, or just selecting 2 points from all the points. Now I'll push that into an array 6 1 3 10. What I did, I'm selecting this as my upper line and how many ways I can make a trapezoid, and I'm just multiplying it 6 into 1 plus 6 into 3 plus 6 into 10, right? Now 1 into 3, selecting top line and then bottom line, 1 into 3, selecting top line and then bottom line, 1 into 10 plus 1 into 10, then 3 into 10, that's it, right? Now if you see here, here, if I just make a sum, all this, the sum will be 20. Now, let me write it as 6 into 1 plus 3 plus 10. Here, 1 into 3 plus 10. Here, 3 into 10. Right? Now, I didn't I didn't get a 6 here. If you see, if I just take it as 6 into 6 plus 1 plus 3 plus 10, right? So I didn't get a 6 here. Okay. Now I only got 1, 3 and 10. And then I removed 1 for this. I removed 1 and then I removed 3 and got only 10. So let me name it as sum. So this is the sum. But sum was initially 20, right? Sum was initially 20. Now what I'll do is for every element in, let me name it as segments, right? So sum minus is equal to element, right? So here I got only 14, 10 plus 3 plus 1, 14. 14 14 sum into element, wait a second, sum into element will be added to total, right? So this will be repeated again and again. Total was 0 firstly, but we don't consider about that. We are only considering about 6, right? So first element was 6. Okay, first element was 6 and the sum was 20. Sum was 20, right? So 20. Now sum minus is equal to element. Element is 6. So sum will be 14. Total is equal to element into sum. That's what I did here. Total is equal to element is 6 and sum is nothing but 14. That's what I got here. Now after that, next element is 1. Now 1. What I did, sum minus is equal to element 13. That's what I got the sum here. Now total is equal to element into sum. Element is 1 into sum is 13. That's what I got here, right? Now after that, going to 3, the sum will be element will be the, nothing but 3 will be subtracted from 13, which will give us 10. Now sum is 10 and element is 3. 3 into 10, that's what I got here, right? And then next element is 10. 10 minus 10 is giving me 0. Sum is 0. Total is equal to element into sum. 10 into 0 will give us nothing but 0. So we are just adding it. So this is the easiest way to get the pairs or segments, right? So just if I write the algorithm, start with let us just start with initializing segments. But if you see, I need to count how many are there, how many points are there at a coordinate, y coordinate 4, where how many points are there at 3, how many points are there at 2, how many points are there at 1. So before initializing this segment, let us go with unordered map. Unordered map int comma int. Now int comma int mp. Now I got points, right? For point in points, right? So the x axis will be 1 comma 4 and 2 comma 4, something like that. So we are only concerned about 4. So mp of point of 1 plus plus, we just got all those points. Now segments, that's what we need. For auto x comma y in mp unordered map, what I'll push back is segments dot push back y. We are just pushing back the count, right? Count, right? But we are pushing this 4. Instead, what we have to push back? 4 into 3 by 2, 6. 2 wait a second, 2 into 1 by 2, 1, I need to push back 1, 3 into 2 by 2, I need to push back 3, 5 into 4 by 2, I need to push back 10, right? So instead I'll push back y into y minus 1 by 2, right? So y into y minus 1 by 2. Now, what is the sum? Sum plus is equal to y into y minus 1 by 2. Y into y minus 1 by 2. This is the sum. Now, what I said? Segments. I'll go through these segments. Now, sum minus is equal to element, total is equal to element into sum. That's what I'll write here. For element in segments, sum minus is equal to element, and sum minus is equal to element, total plus, wait a second, total plus is equal to sum into element. Now we need to return the total at the end, but we have to make sure it doesn't go like the answer may be greater than 199%. So we'll be using a mod operation. Let us see how we can do this mod operation from the code, right? So this is something like default which I got the code, right? So sum is equal to sum minus segments of I, total is equal to 1 ll segments of I into sum. But if the sum minus segments of I is going negatively, it is going lesser than 0, so that's why I have added mod and also did a mod operation with mod. Right now, total is equal to total plus 1 ll into segments of I into sum. I am doing the mod operation for this, right? Segments of I into sum, I am doing a mod operation for this, and again for the total and returning the total at the end. So this is how you solve this problem. And if you have any doubt, please comment in the comment section. And here also I'm using k instead of just getting y into y minus 1 by 2. So these are the two times where I will get this, I will use this mod operation, right? So if you have any doubts, please comment in the comment section, and I have given the code link in the description. Thanks for watching this video.